All right, boys and girls, welcome back to the drive-thru for a remix. Shout out to 4-day weekends. Spring is here. The weather is beautiful. Additional shout out to Ben Kleindorfer. I don't know if you guys know who Ben is. He's a sophomore. You can thank him for this super high fidelity projection screen that we now have a brand new light for. So thanks, Ben. We won't try to do it exact. All right, very tough problem here. So, this is what this week's going to be like. Not a lot of new concepts, but a lot of very challenging problems. So, we've got some big numbers here, so I'm going to make every unit on my graph worth 2, but I'm not going to forget about the fact that I'm going to make every unit on my graph worth 2. So, the point 10, 2, we'll write here, we'll write here. Okay, and the point 18, 17, let's see. Here, 2, 4, 6, 8, 10, 12, 14, 16, 17. H and K. And then we've got this line, a vertical line at x equals 2. Man, I wish they would have put that at x equals 4. I bet it would have made this nice, easy number for the answer. But it's not, okay? So, they're asking, if H went to the pink line and bounced off to K, what would be the shortest possible path for it to bounce off, okay? Well, you could imagine that if it went down here and then back to there, that would certainly not be the shortest path, okay? And similarly, if it went all the way up here and back down, that would not be the shortest path. So then you'd have to like kind of think, well, what if it went directly to the left, which would be 8 units, and then angled up there, okay? And how would that compare, maybe, to going up to this one and over from there? Well, I think the first one would be a little bit shorter, but I'm not exactly sure. As it turns out, and I don't really know how to prove this to you, but I know I could prove it to you, the shortest path between 2 points is a straight line. You know that to be true. So if you wanted to imagine where on this line point J would be, you should reflect either point H or point K across the pink line. So we'll do K. Well, we'll do H. It's just quicker. So we got 1, 2, 3, 4. 1, 2, 3, 4. So we're going to call this H prime. And H prime is at the point -6, 2. Okay? So I want you to notice that the shortest distance from here to here is definitely that line, right, like that. That's definitely the shortest distance from K to H prime. However, the next thing I want you to notice is that that segment and that segment are the exact same lengths. Do you follow that? So, now we know that wherever this point is where point J needs to be to minimize the distance from H to J to K. Do you guys agree with that? And notice, they're not asking us where point J is. They are just asking us how far is it from H to J to K. Well, instead of going from H to J to K, I'm going to go from H prime to J to K, because H prime to J to K is a straight line. So all I'm going to do is make a right triangle out of this. And granted, I could easily do the distance formula, but when I'm working on graphs, this is just easier for me. Let's see, this is going to be 16, right? Yep. And this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. This is going to be 24, and that's what we're looking for. So 16 squared plus 24 squared equals x squared. Help. 16 squared plus 24 squared is 832. Square root that. And it says to round it to the nearest tenth, so 28.8 is our minimum distance. And we'll look that up, and if it's correct, we'll post this on the internet, and if not, we'll act like it never happened. Did I mess something up? What's that? Oh, the 16 is a 15. Okay, we're not done yet. We can fix that. We can fix that. We can fix that. Huge. Colby, I always know that you got my back, just so you know. Always. 15 squared plus 24 squared. 801. Square root of 801. 28.30. Is that right? Finally. Boom!